Hello students, welcome to my class. Today I will teach you mole concept, which will include molar mass, molar volume, Vapour density and empirical formula. In my previous video of this chapter, I had explained Gay-Lussac's law, Avogadro's law and solved many numericals related, and I had asked you to solve the exercise, and I am sure you have followed it. And in this video also I will try to explain the concept so that it becomes simple for you to understand, and I will be solving many numericals which will help you to solve the exercise, and I am sure you will be able to do it without any difficulty because I am going to do a number of questions for you. So please like, share and subscribe my channel, and please don't hesitate to put the doubts in the comment section for me to clear. So let's begin the chapter mole concept, and in this chapter I will be explaining mole, Avogadro's number, molar volume, molar mass, Vapour density, empirical formula, molecular formula and the numericals. I will also explain one or two topics which you had done it last year, but yes, for the revision point of view. Okay, so let's begin. So the first topic that I have taken is relative atomic mass or the atomic weight. So it is the relative atomic mass which tells us that how much this element is, how many times comparison to 1/12 of the mass of the carbon 12. So actually the definition says the atomic weight of an element is the number of times one atom of an element is heavier than 1/12 times the mass of an atom of carbon 12. So this you had learnt it last year also, and you had also solved numericals based on it. So it's just a revision, like oxygen 16, nitrogen 14, you know, many more, hydrogen 1. Okay, we will be doing some more in this video as well. We had done it in the last one also. Okay, so the next topic is relative molecular mass, or the molecular weight of an element or compound is the number of times one molecule of the substance is heavier than, again, 1/12 of the mass of an atom of carbon 12. So the standard that we take is C12 carbon atom. And one example, let me say sulfuric acid H2SO4. So 2 into 1 because hydrogen's atomic mass is 1, plus 32 because sulfur's atomic mass is 32, and 4 into 16, you know why, and the sum total is 98. So we had done this and I have just revised. Now the new topic for you, this one, is gram atomic mass. So if I say 1 gram atomic mass, what do you actually mean? It is the atomic mass of an element, whichever element we are talking about. So gram atomic mass is the atomic mass of an element expressed in grams. Like if I say 1 gram atom of oxygen, I am talking about 16 gram of oxygen. If I say 1 gram atom of helium, I am saying 4 gram of helium. Similarly, gram molecular mass, this also we represent as capital G, capital M and capital M, GMM. So gram molecular mass, it is the molecular mass of the substance expressed in grams. Like if I say 1 gram molecular mass of water, I mean 18 grams of H2O. Similarly, if I say 1 gram molecular mass of ammonia, I mean 17 gram of NH3. So at the same time, if I say 2 gram molecular mass of ammonia, how much is it? 17 into 2, that is 34 gram of NH3. Okay, so 4 topics we have done, 2 of this are repeated and these 2 are something which is done this year. Now the next topic. So we are talking about mole. This is a new topic for you. Easy, children, don't get panic because I will explain it very nicely to you and you will see that how well you understand. Okay, so let me first tell you what it is. A mole is the amount of pure substance. How much pure substance? Containing the same number of chemical units as there are atoms in 12 gram of carbon 12. So 12 gram of carbon 12 contains how many atoms? As the equal number of chemical units is called 1 mole. So I repeat it, 1 mole is the amount of pure substance containing the same number of chemical units, how much? As there are atoms in 12 grams of carbon 12. So when I say a mole, how many number? It is a collection of 6.022 into 10 to the power of 23 particles, which are also known as Avogadro's number. So a mole is a collection of how many particles? Avogadro's number. What is the number? 6.022 into 10 to the power of 23. Now I will relate this GMM, this mole and Avogadro's number with molar volume also. How? See, if I say 1 GMM means 1 gram molecular mass, I am talking about 1 mole. If I am taking 1 GMM, that is 1 mole, I am talking about how many molecules? I am talking about Avogadro's number of molecules, that is 6.022 into 10 to the power of 23 molecules. And if it is a gas, it will occupy 22.4 liter at STP, and this is known as molar volume. Should I repeat? 1 gram molecular mass is 1 mole. 1 mole means it contains Avogadro's number of molecules. If it is a gas, it will occupy 22.4 liter at STP. So the molar volume is 22.4 liter. Volume occupied by 1 GMM of a gas or 1 mole of a gas at STP, exactly what we discussed here. Example, if I have, like I was talking about this 1 gram molecular mass of ammonia, I have taken similar example here, 1 mole of NH3. So what is the molar mass? Nitrogen 14 plus 3 into 1, 17 gram. So 1 mole will weigh 17 gram, 1 mole will weigh molar mass. 1 mole, since ammonia is a gas, will occupy 22.4 liter at STP. And if it is 1 mole, how many molecules? Avogadro's number 6.022 into 10 to the power of 23 number of molecules. Up to this we had done it. Now, just now we had discussed these many things: 1 mole, gram molecular mass, molar volume, the 4 things that we discussed. Now the next part, if it is ammonia, the formula is NH3. How many nitrogen atom? 1. And how many hydrogen atom? 3. So 1 nitrogen atom doesn't mean only 1 atom of nitrogen, it means Avogadro's number of nitrogen atom, like 6.022 into 10 to the power of 23 number of nitrogen atom. And since there are 3 hydrogen, so the number of hydrogen atom is not just 3, it is 3 into Avogadro's number of hydrogen atoms. This was new again, because till last year what we were doing, that one molecule of NH3 has got 1 nitrogen atom and 3 hydrogen atom, just to explain you the molecular formula of a compound, which we were doing in our junior classes. Now since we have now come to the concept of mole, we have to understand that if it is 1 mole, it will occupy Avogadro's number, like 6.022 into 10 to the power of 23 molecules in that 1 mole, in that one formula of that compound. And that formula contains how many atoms? That number into the Avogadro's number is the number of that atom, that element. Like it is 1 nitrogen, so it will be Avogadro's number of nitrogen. It is H3, so it will be 3 into Avogadro's number of hydrogen atom. This you have to understand, children. Okay, now next topic we will go to. But before going to the next topic, I would explain you 2-3 examples so that when we solve the questions it becomes simple for me to explain as well as for you to understand. So the first example that I have taken is, if the question is 14 gram of nitrogen contains how many molecules? Like in the previous question I said 1 mole means 1 mole of ammonia means 17 gram, it contains Avogadro's number. Now question is 14 gram of N2 gas. Now we all know that N2 gas means 1 mole of N2, and 1 mole of N2, what is the mass? 14 into 2, 28 gram, that means this is the molar mass. Now we can say that 28 gram of nitrogen, that is 1 mole of nitrogen, will contain Avogadro's number of molecules, which we did it just now, we understood. Then the question is about 14 gram of nitrogen. So if it is 14 gram of nitrogen, it's exactly half of this. So it will be half of Avogadro's number as well. So 3.011 into 10 to the power of 23. But in most of the cases, it may not be the exact ratio of 1:2 or 1:3 or 4:1. It may be a different fractional also. So in that case, we will go by the unitary method. Like the factor which I have to find out will be on the right hand side, and the factor which is known is always on the left hand side. Now here the mass is given, you have to find out the molecules. Sorry, so 28 grams will contain these many molecules. 1 gram, unitary method, 1 gram will contain these many molecules by 28. So 14 grams will contain these many molecules by 28 into 14. When we cancel 14 and 28, we get 2 in the denominator, we cancel and we get 3.011 into 10 to the power of 23 molecules. Okay, so a similar question, one more question, like in the previous one when I had explained you about 1 mole and the number of molecules, I had also explained you about the number of nitrogen and number of hydrogen present in the molecule. Now I will be explaining one on that basis. So if it is a question that 111 gram of calcium chloride will contain how many chloride ions? Now this CaCl2 is made up of 1 calcium ion and 2 chloride ions. Okay, this we know, this we have done it in the junior classes. In 7th standard itself we had taught you how to form the compound, so we know this. So here calcium is 40, chlorine is 35.5 into 2 is 111 gram. Now you will be asking me, teacher, what about the atomic masses? So I can guarantee that these atomic masses will be given to you. But you know what, by the time you solve many of the questions from your text, you will be learning it also. It will automatically get learned, because you know, it is not about including all the 100 elements in our calculations. We because I had told you that I will be sticking to your syllabus, children. So in our syllabus, as for standard 10, we don't go for many elements. Some of them come again and again, you come across and you write. So by the time you complete the exercise, you have already learned. But I assure you that the atomic masses will be given to you. Okay, so coming back to calcium chloride, if it is 1 mole of calcium chloride, what will be the molar mass? 40 plus 2 into 35.5 is 111 gram. That means when I am given 111 gram, I am talking about 1 mole. That means 1 mole. 1 mole contains how many molecules? How many chloride ions? There are 2 chloride ions. So how many chloride ions? 2 into Avogadro's number, and the product is this. So this was only directly about molecules. This was about how many chloride ions are contained in 1 mole. So if the mass is given, we first find out how many moles are there. On the basis of that, we calculate. Like here 1 mole is 2 chloride ions, so 2 means 2 into Avogadro's number. Please just don't write 2, it is wrong, children. It is 2 into Avogadro's number product, and give the answer. Okay, so up to this about mole we discussed till here. Our next topic, little similar, but you know what, it's going to be even simpler for you. So if the question is this is a known fact actually, 28 gram of N2. In the previous question we had just done, see 28 gram means 1 mole. So when I am saying 28 gram of nitrogen, I am saying 1 mole of nitrogen. So what will be the molar volume? It is 22.4 liter, where at STP. So mass of 1 mole of nitrogen, yes, we all know it's 28. How? 14 into 2, 28. That means 28 gram of nitrogen will occupy 22.4 liter. So how much would 2.8 gram of nitrogen occupy? Again, unitary method we have done. I just explained you in the previous slide. So it is a similar calculation, and the answer is 2.24 liter. One more question. If 1 mole of ammonia, we had done 2 questions on ammonia. I am taking one more. So 1 mole of ammonia will occupy, we all know molar volume, how much? 22.4 liter at STP. So if it is 3 moles, how much will it occupy? 3 into 22.4 liter at STP. Unitary method again. So we are using that method because that is simple. You have done it, and it's easy for calculation, and you will not make mistake. That is the point. I have taken one more question. 1 mole of oxygen, if it is oxygen O2 gas, it is 16 2s are 32. So 1 mole of oxygen, molar mass 32 gram, will contain how many molecules? 6.022 into 10 to the power of 23 molecules, Avogadro's number. So actually what we are implying, back direction, 6.022 into 10 to the power of 23 molecules will weigh 32 gram. So 1 molecule will weigh 32 by 6.022 into 10 to the power of 23. Calculate. I have done it. You all can make a rough column on the right side of your page. Calculate, divide or multiply, whatever is needed, and write the answer as it is. Unitary method. I will take one example on gram molecular mass because that is introduced this year. So when I had done gram molecular mass, I will go back to show you. Yes, see, 1 gram molecular mass of water is 18 gram of H2O, 1 gram molecular mass of ammonia is 17 gram of NH3. So this we have done with 2 examples. I will go back with water. So if I have 18 gram of H2O, how much do I have? I have 1 gram molecule of water. So if I have 4.5 gram, how many gram molecule do I have? If I have 18 gram, I have 1 gram molecule. If I have 1 gram, I have 1 by 18. If I have 4.5 gram, I have 1 by 18 into 4.5 is 0.25 gram molecule. I have shown this because you will be needing this calculation when you solve the exercise. Okay, I will go to the next slide, and our next topic is vapor density and empirical formula. Actually we can find out the molecular formula from empirical formula knowing the vapor density. So I will be solving examples only, then it's going to be more clear to you. So if I say vapor density and empirical formula, we should know what is vapor density. The relative vapor density of a gas is the ratio between the masses of equal volume of gas and hydrogen. Like if you have 2 volume of gas divided by 2 volume of hydrogen under the same condition of temperature and pressure. So when this ratio is being found out and the masses are calculated of that gas and the volume, the condition should remain the same. This ratio is known as the vapor density. And there is one relation which you all should remember, that is 2 into vapor density is equal to molecular mass. For example, if the vapor density of a gas is 45, then its molecular mass is 90. If the molecular mass is 90, then the vapor density is 45. So it's a relation of multiplying and dividing by 2, that 10 standard. I don't need to explain that to you. But yes, this relation you should remember because this is going to be needed when we solve the questions on molecular formula. Now coming to empirical formula. Children, before going to the empirical formula, let me remind you once, there are many terms in this chapter and you may get to define them. Please learn the definitions from your text. Let me repeat, stick to the syllabus, read the chapter, and the definitions please learn from your text. Okay, so empirical formula. Empirical formula is the simplest formula which gives the simplest ratio in whole number of atoms of different elements present in one molecule of a compound. Now, to explain, let me tell you, we all know glucose C6H12O6. If the ratio of carbon, hydrogen and oxygen is taken, what do I get? CH2O. How? 6 ones are 6, 6 twos are 12, 6 ones are 6. So, the common factor is 6. Therefore, the empirical formula of glucose is CH2O. I hope it's clear. This was done last year, but we had not gone into the detail of how to find out the empirical formula. We had just told you that how to bring down to empirical formula by dividing them by a common factor, that is putting them in the ratio form. Further details we had not done, which we will be doing now. So, coming back to empirical formula, it is the simplest formula, gives the simplest ratio in whole number of different elements present in one molecule of compound, and glucose is a very simple example. You can also understand this way: hydrogen peroxide H2O2. So, the empirical formula is HO. Like if it would have been water H2O, the empirical formula is also H2O, because there is no common factor which can divide. Here the common factor is 2, so H and O, so the ratio is 1:1. Now, we to calculate the molecular formula, we also need one more calculation, that is empirical formula mass. That means whatever is your empirical formula, we find the mass of that. Like if it is the empirical formula mass of hydrogen peroxide, it is HO, hydrogen 1, oxygen 16, 16 plus 1, 17. Had it been the empirical formula mass of glucose, it would have been 12 plus 2 into 1 plus 16. So, this we will need. Okay. Therefore, I had showed just one example to you all. Let us go to the next slide. Okay. So, the question is find the number of moles in 10 gram of calcium carbonate. So, we now go back to the concept which we were doing in the first 2 slides, actually 3 slides, where we were relating moles, molar mass, molar volume and number of molecules, that is Avogadro's number. Here the question is, find the number of moles which are present in 10 gram of calcium carbonate. So, we all know calcium carbonate's molecular mass, that is the molar mass. That means 1 mole of calcium carbonate would weigh how much? Calcium 40, carbon 12, oxygen 3 into 16, and it is 100 gram. So, it implies that 100 gram of calcium carbonate means 1 mole. So, 10 gram of calcium carbonate means 0.1 mole. Again, I will not repeat, because we by now you all must have understood how to solve by unitary method. So, I will not waste time explaining that steps. I will just explain the concept on basis of which you are going to calculate. So, if the question is given the mass and finding the number of moles, what you have to do is you will have to straight away go to calculate the molar mass, which is 1 mole, and on the basis of that 10 gram will weigh will be equal to how many moles. Okay, next question. Find the number of molecules in 16 gram of sulfur dioxide. In the previous question, find the number of moles in the mass. Here, find the number of molecules and the given mass. So, the compound is sulfur dioxide. We straight away go to the molar mass, that is 32 plus 16 into 2 is 64 gram. That means, if you have 64 gram of sulfur dioxide, means you have 1 mole of sulfur dioxide, means you have Avogadro's number of molecules 6.022 into 10 to the power of 23. Therefore, 16 gram of sulfur dioxide would contain these many number of molecules. Okay students, this was more of a conceptual part of the mole concept chapter, where I have tried to explain different topics with proper examples. And in my next video of this chapter, I will be doing more numericals on these topics, which will be a revision, as well as I will try to prepare you for the final exam. And you can try out the exercise by now, and you will get help in my next lecture video also. So please like, share and subscribe my channel, and hit the bell icon to get notified of my upcoming video. Thank you, children.